Okay, in this video, I'm going to show you guys how to derive the vertex formula of a parabola. In another word, I'll show you the vertex of the graph of y is equal to ax squared plus bx plus c. It's at x equals to negative b over 2a. And I'm going to show you guys two ways to do this. The first way is the algebra way, and the second way is the calculus way. And maybe you haven't seen calculus before, but hopefully you can pick up some of the concepts and ideas from my presentation. Let's get started with the algebra way first. And to do algebra for this, we have to complete the square. So let me write this down right here for you guys. CTS, which stands for completing the square. And notice we cannot use the quadratic formula yet because the quadratic formula is actually based on CTS, right? So this right here, it's a deal. And now let me write this down again. We have y equals to ax squared plus bx plus c. Whenever we want to complete the square, we want to make sure that we have a 1 in front of the x squared. But in this case, we have a, so what can we do? It's not a big deal, right? Because we have an equation, so we can just divide everything by a. And we know this is the jet because a has to be not equal to 0, because if a was equal to 0, we wouldn't even have a parabola in the first place. So we can totally divide everything by a. And now, on the left-hand side, we will have y over a, and this is equal to a over a is the 1 that we want, right? And then we have the x squared, and then plus b over a times x like this. And we want to focus on the x squared term and the x term, namely these two terms, right? After we have these two terms, we are going to leave a space right here for a magic number, you will see. So we will have a space right here for the moment, and then we'll write down the plus c over a right here. And now, once we have this, what do? We have to talk about the magic number. So, in order for this to work, be sure we have to have a 1 in front of the x squared, which we do, right? So we can proceed. And this is the formula for the magic number. We are going to take a look of the coefficient of x. In our case, it is the positive b over a right here, right? And what we want to do is, we are going to look at the number. We do 1/2 times the coefficient right here, which is b over a in our case. Put this right here in a parentheses and square that. This right here is the formula for the magic number. It's always 1/2 times the coefficient of x, and then you square that. Be sure the 1 has to be in front of the x squared already, all right? Okay, so let's just work this out. Now you see b on the top, right? 1 times b is just b, so we have b squared is just b squared over. On the bottom, we have 2 times a. Square that. 2 squared is 4. A squared is just a squared. This is the deal. We are going to add this right here. We put down plus b squared over 4a squared. But you see, on the right-hand side, I just add this blue magic number here, right? Be sure we also subtract this right away at the end right here, so that I'm just pretty much adding 0. I'm adding nothing, right? This and that will cancel out. But the best part of doing this is that these 3 terms right here, it's going to be factorable. And the crazy part is that both of the factors will be the same. Therefore, we can produce a perfect square from here. So you can try this whichever method that you want. But in general, when you factor it, you get x times x like this. And you ask yourself, what times 4 give you b squared over 4a squared? And when you add them up, you get b over a. And the answer for that is b over 2a, b over 2a. This times this gives us b squared over 4a squared. And when you add these two together, we get 2b over 2a. So the 2's cancel. We do get b over a right here for the middle, right? So that's great. And now you see, this is what we have. We can write this down as the following. This is y over a equal, this right here is now x plus b over 2a, and then square, and this, plus c over a minus b squared over 4a squared. Well, in the end, we can just multiply everything by a so that we have the equation in the form that we want. So let's go ahead and do that. When we multiply, be sure to distribute, right, the good old things like this. So this times this, we have y, and then we put the a times this, right? So this is one term, so we have the a in front. So a times x plus b over 2a squared. This times that, a cancels out, we have plus c. This times that, one of the a in the denominator cancel out. So we have minus b squared over 4a to the first power. Because a over a squared, we have just a to the first on the bottom like that. So this is pretty much what we want, because this now is the vertex form of a parabola. And let me remind you guys the general form of the vertex form of the parabola. Whenever we have the equation in this form, we know precisely that the vertex is at h, k. And what we're trying to achieve is that I will try to show you the vertex formula, the vertex of the parabola is at x equal to negative b over 2a. And that's exactly the h value in this form. And if you look at this, we have everything pretty much set up. We have the y by itself, and then we have the a match, we have the x and x match, right? However, pay attention to the inside. We have x, but this is the plus, this is the minus. So we have to do a small fix. Right here, we are going to rewrite this as x minus, well, originally I had a plus, so what can we do? Well, we are going to look at this as negative b over 2a, because negative times negative gives us a positive, isn't it? So this is the deal. And I just want to show you, from here, we can pick out the h value, which is this, negative b over 2a. So I can conclude for you guys that the vertex of the parabola in that form is at x equal to negative b over 2a, right here. All right? And usually I just tell my students, remember this, and just use this formula to work out the x value for the vertex. And then once you have the x value, plug back into the original equation so you can get the y value. But if you want to find out the y value, namely the k, it's just this. But this right here is the deal. The vertex of the parabola is at x equals to negative b over 2a. That's all. So that was it for the algebra way. Now let's move on to the calculus way. And to do calculus for this, we have to talk about the derivative. So let me write this down right here. And I'm just going to do a quick intro with derivative, right? Just like a quick explanation, right? So we are talking about the equation y is equal to ax squared plus bx plus c. And we know the graph of this, it's going to be either open up or open down parabola. So let me just give you guys a quick picture like this. And our goal is to figure out where is the vertex. Namely, in this picture, it will be the lowest point here. And in this picture right here, is the highest point right here, right? And we're trying to figure out the x value of the vertex right here and right here. And here is the interesting part. Imagine you just hold out a pencil or marker and place the pencil at this point on the curve. You will notice that the pencil becomes horizontal. The marker becomes horizontal, right? Likewise, if you do it right here as well, the marker is going to become horizontal right here. If you put a marker at a different point, of course, it's not horizontal anymore, such as right here, right? But anyway, this right here, it's a concept of tangent line. Once again, just imagine you place a pencil, a marker, a pen, whatsoever. We have a horizontal tangent line because the marker is horizontal like this now, right? And that's what exactly derivative will tell you. Derivative will tell you the slope of the tangent line, right? And notice right here, let me just draw this. When you try to draw a tangent line at the lowest point, the slope of this line is going to be 0 because it's flat. Likewise, if you draw the tangent line on the highest point right here, the slope is also going to be 0. And that's true in general, in all the situations actually. Whenever you draw the slope, whenever you draw the tangent line at the lowest point or the highest point, the slope of those tangent lines will be 0 because they are just horizontal like this. And let me just label this right here with m for the slope. M is equal to 0. And this right here, m is equal to 0 as well. So what we want to do is we are going to do what we call the differentiation to this equation. And the notation is the following. We can put down d dx to mean that we are going to differentiate this equation. And this right here on the left-hand side, you have a few ways to write this down. You can write this down as, in a blue pen maybe, you can write the result as y prime or dy dx. This right here, both of them, they just mean that the derivative. In other words, this right here will tell you the slope of the tangent line at whatever point that you want, right? So on the left-hand side, let me just use this notation right here. So I'll write down y prime, and you can use either one, doesn't matter. And now the question is, well, how can we do this operation, right? This is not bad at all because we have a polynomial, and we can use what we call the power rule for taking the derivative. So let me write this down right here. This is the power rule. Whenever we want to take the derivative, when we have x to some number, right? So x to the nth power like this. And in this case, n can be any real number, including negative, it can be fraction, whatsoever. And just like what I put down right here, when we want to differentiate, right? That's another way to say take the derivative. So put on d dx like this, right? So to differentiate this, or to take the derivative of this, what we do is we first take the power, bring that to the front. So we will have n times x. And for the new power, we are going to actually minus 1 from the original. So the new power right here is going to be n minus 1. And that's it. And we can use this for the first term, second term, and the third term. We have a constant multiple, right? But we'll just multiply the result with the derivative. So that's okay. But of course, later on, things will get more complicated. But at the moment, this is actually not bad at all. So now, let's see. We are going to be taking the derivative of this. For the first term, we have a times x to the second power. This part right here, we can use the power rule right here. So I'm going to bring the power to the front. Notice, then we will have 2 times a, so that's 2a. And then we are going to minus 1 to the power, so we will have, what's the new power now? Well, it's x. 2 minus 1 is of course 1, but let me just put it down like this, right? So this is not bad, as I said. This is it. This is calculus. And now for the next term, we have plus b times x. And x means x to the first power. So we can bring the 1 to the front. So it's just plus 1 times b. So you can just put down b. And then this is what? Don't forget to minus 1. So we have 1 minus 1, which becomes 0. So x to the 0th power, we know it's just 1. B times 1 doesn't matter, right? And in the end, we have plus c. Can we still use this? Yes, if you would like, you can put down c times x to the 0th power, and then you can bring the 0 to the front, and you notice 0 times c is just 0, so at the end right here you have plus 0. Minus 1 doesn't really matter, it's 0 anyway. So in other words, the derivative of this is just that y prime is 2ax plus b. So this right here is the derivative of the parabola, right? Well, what good does this do? Keep in mind, we want to make sure, we want to find out the x value so that the slope at that x value is 0. The slope at the vertex is 0. This right here will tell you the slope of the tangent line. And I want to know for what x value will make this right here equal to 0. This is how we find the minimum or the maximum, right? And of course, this right here is just for parabola, but later on, you can use calculus, the derivative techniques right here, to do other curves as well. So we are going to focus on this. Of course, we have the 2ax plus b. We can move the b to the other side. So we have 2ax equals to negative b. And you guessed it, we can then just divide both sides by 2a. And we are done. X is equal to negative b over 2a. This is pretty much it. And this right here is also going to tell us if we have a minimum or maximum. Depends if the graph opens up or opens down, right? And now let's go back to algebra again. Back in algebra, your teacher will tell you, let's look at the a value. If a is greater than 0, then the graph will open up, right? So now let me write that down for you guys. This is a situation when we have a being positive, like this. And on the other hand, if a is less than 0, if a is negative, we will have this situation. The graph will open down, right? Okay, have you guys ever wondered why? Now we can explain this idea better by talking about derivative. However, the first derivative is only telling you that the slope of the tangent line. In order to talk about how does the graph open, either open up or open down, we have to talk about the derivative of the derivative, namely the second derivative. And now, this is just a little bonus part before we go. The original is that y is equal to ax squared plus bx plus c. And the first derivative is already here, is 2ax plus b. And we can differentiate this again by using the power rule. So I will put down y double prime like this. This right here represents the second derivative. And this is going to tell you how does the graph open. Either open up or open down, depending on if you have a positive second derivative or negative second derivative. But anyway, let's get to work first right here. So when we differentiate this part, you see 2 times a is just a constant multiple with x, right? And this is x to the first power. You can use the power rule again. You can bring the 1 to the front, and then minus 1 right here. X to the 1 minus 1, namely x to the 0th power, is just 1. So you pretty much will just have 2a left. And notice, this is just a linear term. The derivative of a linear term is always just going to be the coefficient, because that's the slope, right? So just 2a. And now if you look at plus b, there is no x, right? So you know the derivative of this is going to be 0. You can do this kind of things as well if you would like, but you know if there's no variable, this right here, the derivative of that is going to be 0 because it's just a constant, it doesn't change. So notice that the second derivative of the parabola is just 2 times a. It doesn't depend on x, right? It only depends on the a value, nothing else, right? And this right here, the second derivative is going to tell us what we call the concavity. Meaning, if you have a second derivative being positive, the graph will open up. If the second derivative is negative, the graph will open down. If the second derivative is 0, that's called the point of inflection. But let's just talk about the following. You see, if a is greater than 0 in this case, 2 times some positive number, we will end up with a second derivative being positive. So that's this situation. When we have the second derivative being positive, the graph concaves up, right? Opens up. And it's always open up because, well, it's just 2 times a. It only depends on the a value. And likewise, if a is less than 0, namely if a is negative, 2 times a negative number right here, it's always negative right here. So we will have a second derivative being negative, and that's this situation. When we have the second derivative being less than 0, the graph opens down, namely the calculus word right here is concaves down. And this right here is pretty much what the second derivative tells you. It tells you if the graph opens up or opens down. And of course, a lot of things can be said about the first and the second derivative, and there are other techniques to take the derivative besides the power rule. But if you haven't seen calculus before, hopefully this video provides you with a good insight about what calculus can do for you, especially later on if you have to deal with a more complicated function other than the parabola. Well, the algebra may not work for you. You may have to really use calculus, right? But anyway, this is it for the video. Comment down below and let me know what you guys think, alright? That's it.